Okay, so kind of a weird title, right? So in this talk, I'm going to do a deep dive on something called higher order components. It's not really the most exciting talk compared to some of the things we've seen today, or the topic, I should say. Hopefully the talk's exciting. So I know I got my work cut out for me a little bit, but I wanted to talk about it for a good reason, I think. I think the subject is ripe for discussion because there's this thing that is in React that a lot of people are aware of. Most people are, passingly familiar with it. Whether you know it or not, you've almost certainly used it if you've ever used React. And yet, in my view, they've yet to kind of really take off as a design pattern for developing React applications. So I just want to do a deep dive into them. The first thing I'm going to talk about is just what higher order components are and how they work. Then I'm going to illustrate some of the use cases and trade-offs that they present. And finally, I'll discuss some strategies for improving the performance of higher order components, because that is sometimes one of the current concerns when you use a lot of them. And throughout the talk, I'm also going to discuss an open source library I created last fall called Recompose. And I'll just say I open source projects from time to time, and sometimes I do it before I'm 100% sure if the project is a good idea. I'm guilty of that several times, and if it's not, eventually it fizzles out and dies. And so at first I was not confident at all that this particular project, the idea behind it was solid, and I considered it very experimental. But after a few months of using it in my apps, I can say that I've used Recompose in most of the components I've written during that time, and my team has, and we've been using it in production, and there have been some really cool benefits from it. So I hope to be able to communicate what I find valuable about the library, and maybe you can tell me why I'm wrong. So first, just a quick review. What is a higher order component? So it turns out it's a fancy name for what's really a very simple concept. They're functions that accept a component and they return a new component, and that new component's behavior is enhanced. And that's really it. That's what a higher order component is. And I might also say, people say HOC kind of colloquially because it's less of a mouthful, so if I say that, that's what I mean. They might also accept some additional parameters, so arg1, arg2, but this is still considered an HOC. Or they might use currying, and there's a good reason for this, which we'll see later. But regardless of its exact signature, if you have a function that takes a component and returns a component, then you have a higher order component. So let's look at some examples that you might be familiar with, that you probably are familiar with. The most popular is probably React Redux Connect, and it looks like this. Just takes a component, it subscribes to a Redux store, and it passes down some state props and bound action creators based on the parameters that you give it. Here's another one from React Router that was recently added with Router. It takes a component, passes down some props to the current component. And this is like as opposed to the previous thing that you had to do, which is like use context, which is kind of weird. And now this higher order component just takes care of that for you. In this case, it doesn't really have any additional arguments. It just takes the component. Here's another one. This is relay create container. Slightly different signature, but again, this is still a higher order component. Takes a component, passes down some props. In this case, it's data fetched from a GraphQL endpoint. And it doesn't just pass down props. It'll also delay the rendering of the component until all the data dependencies are satisfied, which is pretty cool. So these three examples, Connect, with Router, Create Container, they have slightly different signatures, serve different use cases, but in each case they are enhancing the behavior of a component, for the most part by passing down additional props and injecting them, but not always just that. So how do they work? How is it possible for a function to change the behavior of a component from the outside? So if you're new to React, and especially if you come from an object-oriented background, as a lot of us do, it may be tempting to think that higher order components are modifying the class definition of the input component somehow, perhaps by adding additional stuff to the prototype or monkey patching the render method. But in reality, it's way simpler than that. Higher order components work by secretly wrapping the input component inside a container component. Okay, so I just introduced a new word there, so let's back up real quick in case people haven't heard that before. Review, container versus presentational components. A container component there's this pattern in React of separating components according to certain types of responsibilities that they have. So some components are designed to be purely presentational. They simply accept props and return some React elements. A lot of times you'll just use a stateless functional component for that, because that seems to make sense. And then other components perform more complex tasks such as managing subscriptions, data fetching, other business logic perhaps, and these are called container components because they do all this heavy lifting before they send props down to your nice presentational components, which are really easily testable and reusable. This is also sometimes referred to as like smart versus dumb components. The Redux docs have a pretty good section on this, and Danny Abramoff wrote a good Medium post on the subject last year, which you can check out. I think most people are probably familiar with this, right? So anyway, to go back, higher-order components work by secretly wrapping the input component inside a container component, right? In other words, they work by composing the original component. There's no like modifying the input components class or anything like that. So here's that same container component I just showed you implemented using a higher order component. And what's nice is that this quote-unquote secret hidden container component is just an implementation detail. Unless you're in React DevTools, it's not something you really need to think about, at least until we get to the last part of this talk where we'll discuss it in depth. You only need to know that an HOC enhances the behavior of a component that you give to it. Now, so this is a kind of a weird one because it's not really clear why this HOC is any better than the other container component. It's coupled to the wrapped component, and so it's not really reusable. What's the point of wrapping it in this extra function? And yeah, in this case, there really isn't much of a point. But if we add a parameter to our higher order component that controls the fetching behavior, now this is more reusable, and now fetch resource rather than fetch post can be used for any kind of resource, not just post. I just realized I didn't describe what this does. It just fetches a resource and then passes it to the wrapped component, right? And now we can customize it for any kind of resource. So here's like the same higher order component fetch resource, which we're using to create a new higher order component called fetch user. And we don't have to rewrite an entirely new container component. We can just reuse almost all of that logic except for this specific mechanism for fetching the resource, right? So I said earlier that higher order components are just functions accept a component and return a component. And while that's a good description of the Surface API, if you want to describe their implementation, I like to say that higher order components are parameterized container components. That's really all they are. They're not really a brand new fancy abstraction. They're just functions and container components, which are, very common things that everybody's pretty familiar with. So they're container components that can be customized and reused for a variety of situations. So now that we've established that, I want to talk about how I've come to use higher order components more frequently in some of the applications I've worked on. So I've been using HOCs as a pattern for a while in like open source stuff. Even before Redux, I had this other modestly popular Flux library called Flumix, which if I'm not mistaken was, if not the first, like one of the first Flux libraries to use higher order components instead of mixins, which is what people always used to use back in the day. And when I say back in the day, I mean like a year and a half ago. It wasn't that long. I'm sure someone will correct me if I got the timeline wrong slightly, but I think that's right. And now, of course, Redux has taken that approach mainstream. Everybody knows how to use Connect. But aside from the HOCs provided by libraries, I didn't often use higher order components in my application code. Well, it's not that I never used them, but my instinct was that they were kind of overkill most of the time, and they should only be used very sparingly for very particular situations. And yet gradually something weird started to happen where I started to discover these use cases where I'm like, maybe I should try this out. Maybe it's not overkill, maybe this would be a good fit. So let me give you some kind of silly examples. Whenever I'm implementing a new feature in a React app, I always start with the presentational components, as I think most people probably do nowadays. Again, those are just components that do nothing except take props and return React elements. And this is a good approach because it forces you to think about the contracts between the different parts of your application. And only after those presentational components are scaffolded then you add the container components and you do the things that are like more side effecty and you actually hook things up and do all those kinds of gross things, right? So when I was working on a presentational component one day, and I don't remember what the particular one was, so let's just say it was that post component that I was showing earlier, I wanted some mock data to work with, right? Because when you're working on, until we have the carte blanche thing, you want some mock data to work on while you're working on your app. But I just didn't want to just embed that into my component, like just plop it in there. I wanted to work with the component as if that mock data were provided as props, right? And I also didn't really want to go to the component that was rendering it and like add it there, because then I have to go to a different module. So I had kind of this silly, weird idea, which is this thing. It's just with props, And all it does absolutely nothing except inject props into the input component. That's literally all it does. And the idea was later that I could just remove this with props and replace it with actual data without needing to change the post component. Now this is kind of ridiculous, right? This is overkill. But anyway, it worked well for this purpose, and eventually I did remove with props, and I started fetching actual data, in my case using relay. And I kind of had this other thing where my relay container was passing down post as a single prop, rather than a separate title and content props. And the reason is just because of how fragments work with containers. It's not a huge deal. Again, this is a little bit contrived, but I did find it the case often that when I was using relay, I didn't want that top level fragment. I wanted like one level deeper. So I wanted the title and content. I didn't really want just a giant post object. That's just the way I happened to do my presentational component. Anyway, the key point is I didn't want to change the API of my presentational component just because I happened to be using relay rather than maybe Redux or something. Again, contrived example, but this similar thing came up a few times. Ideally, I should be able to just plop in any data fetching layer without changing the presentational components at all. So to handle these types of situations, I made another silly little higher order component called MattProps, and it literally, this is MattProps. So again, I felt really ridiculous the first time I used this guy. But despite that, I actually started using this more and more in more and more places. And I even created like some weird specific variants like Flattened prop, which handles that relay thing that I was just talking about. And it literally just flattens like a nested object into the object of props. And I had another one called Rename prop, which was like an entire higher order component literally just to rename a single prop, because I needed it at one point. Anyway, this felt really silly, but I continued to find new uses for these higher order components. Another one is, although I use Redux, sometimes local state is a better solution than managing state in like a application level store. But I didn't really want to use set state either. I wanted to use the Redux paradigm with reducers and actions and so forth, but just locally to a component without actually using Redux. And then as a bonus, if I later decide that the state really does belong in the Redux store, I can just move the component to another module. So I created this guy. It's just with reducer. Pretty simple implementation. It looks a lot like the thing that Dan showed us in one of his slides yesterday. And yeah, just let me use a normal Redux reducer in the form of just by passing it to a higher order component. More examples, I have this one called Pure, which just is like analogous to the Pure render mixin. And then I had like a special version of that called Only Update for Keys, which I would use in those very rare instances when I needed to implement a component update using shallow comparison. Here's another one. When I had to deal with context, I had this with context higher order component instead of having to remember it was just slightly more convenient than having to set context types directly. And there's a corresponding one called get context, which also works. So this is like kind of like a Redux provider in the form of a higher order component. I had another one which I really liked called branch, which acts kind of like an if statement where you give it a test of the props, and if the test is true, it renders this higher order component. And if it's not true, then it renders a different one. So here's like, in a few lines, here's how you can create a higher order component to render a spinner if some test is true, or not render just the normal component if it's not true, and you can just use that show spinner guy like everywhere in your app rather than having to put a bunch of if statements in all your render methods. So the core idea basically here is that I found that these small little utility HOCs can be composed into more useful HOCs. Before I knew it, I had a little suite of higher order components, and it got to the point where pretty much every component I wrote used at least one of these higher order components, and sometimes it used more than that, and I would compose them together. And yet even at this point, the whole exercise still felt gross, and it felt kind of wrong, because some of these higher order components are doing like so little, it seemed wrong. And yet, on the other hand, again, it made my code feel more modular, reusable, and concise. And it let my presentational components remain presentational. I mean, how many times have you started to write a functional component, and then you groan when you realize, oh, I gotta like add something that I can only do in a class, and then you just like kind of groan and you get upset. Well, if you use these HOCs, that kind of fixes that problem, right? And you find that you can keep your presentational components just as function components, and the barrier to entry of using one of these HOCs is a lot lower than writing a container component out manually. But again, on the other hand, again, there are some clear downsides. And for me, the biggest one wasn't really about performance. It was rather like what happens when another developer looks at your code and they see all these weird like APIs that you invented, these weird helper things that doesn't look like anything they've ever seen in React. Now they have to learn an entirely new API just to understand the simple little React component that you decided to make. So this is my biggest problem. And it's especially bad here, like if you're using multiple higher order components and composing them together, like so. Now, so I know what all these guys do, so to me it looks kind of elegant, and maybe like if you're familiar with this show spinner and flatten prop and fetch post like I just showed you, maybe you find this elegant as well. But this is not a common pattern in the React ecosystem, especially at the time, and I knew other developers would have a hard time figuring out what the hell is going on right here. But you know, the thing is, this trade-off is kind of true for any functional utility library. The reason a library like Lodash is so popular, in part, is because Lodash is really popular. Like, it's a stable and well-documented project, and you can add Lodash to your app and be reasonably confident that the next developer is going to understand how to use it, and they're not going to pull their hair out trying to figure out, like, what does, you know, pluck do? So with that in mind, I had a selfish idea for how I could quote-unquote fix my problem. I would just open source my little suite of higher order component utilities and see if anyone else wanted to use them, and then that would justify my continued use of them, and I could go on guilt-free. Very selfish. So I needed a name, so I went to the dictionary. I flipped open to the R section. I found a word that began with RE that seemed like vaguely related, and hit publish, and that's, yeah, then Recompose was born. That's how all great React open source projects are named, right? And yeah, that's really the extent of the thought that I put into naming it. Thus far, I'd say it's been a modest success. It's about like 55,000 downloads a month on NPM, which is enough to convince me that I'm not totally crazy and that some part of this is a good idea. Even after a few months of use, I still sometimes wonder, even right now I'm wondering, if the use of these micro HOCs is like too fraught with compromises. I have seen some excited Recompose users like online take this concept way further than I originally intended, composing together like a dozen higher order components, going to these unnecessary, in my opinion, extremes to avoid ever using classes ever. Adding should component update optimizations all over their app just because it became so easy with this only update for keys thing, even though that's like not a good idea and you should only really use them as an escape hatch. So I've seen some things that kind of concern me about the library. Well, actually, yeah, but yeah, so, sorry. But overall, I've come to really like it, higher order components as an abstraction, as a pattern, in large part because they're kind of barely an abstraction over components at all, right? They can encourage the developer to think more in terms of props rather than in terms of state or life cycles, which is kind of what mixins so often used to do. So I've come to the point where, despite my misgivings, I'm pretty convinced that there's at least some utility to this pattern, even the silly ones like MattProps, and it can be a useful pattern for developing React applications for scale and reuse, and at least they have been in my experience. So now the final section, which is maybe the more interesting part of this talk. If we're going to embrace this pattern of using a lot of HOCs, we need to take a hard look at the other big downside besides introducing this weird API. The other big downside of higher order components, which is all the extra hidden little container components that every single HOC introduces into your component tree. So in this last section, I'm going to discuss some of the strategies that Recompose uses currently and will use in the very near future to optimize for performance and kind of fix this problem. So as I said, the essential performance problem with higher order components is that they result in all these extra component instances, right? Those secret container components that we talked about aren't free. And the fact that they're quote unquote secret and hidden makes it easy to end up with lots of extra components in your component tree without realizing it. So to illustrate, let's go back to our component, or our post component from before. And after enhancing it with our, those higher order components that we were using, this is what it looks like in our code, in the render method of the component that is rendering it. And it looks just like any other React element. We have no idea that there's some secret hidden container components in there. But here's what it looks like in the React Dev Tools. Whoa! So our single component, quote unquote, is actually implemented using 4 components, 3 extra ones that are wrapping it. And now the things in blue are just display names that Recompose uses to illustrate which higher-order components that you've added to your component. They're not actually function calls. They're just to show you what's going on. So if you look here, our presentational post component has been wrapped by 3 additional container components. And this is a shame because if we were just to write post container component manually, it's not that complicated. If we did it the old-fashioned way, we would really only need a single class component for like the whole thing maybe, or maybe one single container component around the post component. And this happens to be one of the advantages mixins had over higher order components, which is that you could add a bunch of mixins to a component, and as long as something weird didn't happen with the clashing of the life cycles, you wouldn't increase the number of component instances. So wouldn't it be great if we could use higher order components and all the benefits they provide in terms of like a model or as a design pattern without creating this new secret instance every time? Well, we might not be able to get rid of all the extra component instances, but it turns out we can get rid of them, of a lot of them, pretty easily. And it's a pretty simple technique Recompose uses to do this. Because post is a stateless functional component, we can just inline it inside the render method of the component that contains it. So in other words, the containing component, rather than creating a React element with JSX, it just calls the functional component like a function, because that's what it is, and just embeds its output directly into the render method. And so Recompose does this using a little utility function that it uses internally called CreateEagerElement. I'm not sure if that name is great, but it's a drop-in replacement for the standard React create element. Typically, React elements are lazy, which means they're not evaluated immediately inside of render, but React rather manages a component like instance for you. But because like almost every higher order component's render method looks just like this, it's just a single child component with some props added to it, this laziness isn't necessarily like buying us anything. So what CreateEagerElement does instead is it just calls the function, or sorry, the component, if it's referentially, if it's what I'm calling, but I'm not sure is technically correct, a referentially transparent functional component, which is like a functional component that doesn't access context, essentially, because you can't do this if it accesses context. And it just calls them directly, like this. And so that means there are fewer component instances for React to keep track of, and I like to call this technique component squashing. And so if we go back to our like DevTools thing, because post is a functional component, now our DevTools look like this. So there's just one fewer component in there. Post went away, and now it's just embedded inside of Flattened prop. And it turns out since Flattened prop is also like really simple, it happens to be implemented using a referentially transparent function component, we're going to squash that one as well. And so now we're down to this. And so both post and Flattened prop are now just embedded inside of show spinner, and our DevTools look a little bit more sane now. Now we can't do the same squashing thing to fetch post, because remember that used a class. But this is actually a pretty good way to reduce the number of extra components created by HOCs just by kind of transparently combining them without you having to do anything different when you're composing them. So, as I said, we can't use CreateEagerElement on class components because they're not referentially transparent, quote unquote. But wouldn't it be nice if there were a way to squash class-based containers as well? And as it turns out, in many cases, you actually can. So this is the thing that isn't released yet, but I have a PR open and it is about to be merged. I'm just like adding some extra tests to it. The thing I just discussed, the eager element thing, that is part of Recompose already, and it has been for a while. Before I explain how this works, because it seems like it's kind of weird how are you able to fuse like components together, I need to introduce you to my favorite Recompose helper, which is MattPropStream. Now this is a higher order component that defines its behavior by transforming a stream that represents the props received from the owner into a stream of props to be sent to the wrap component. So whereas like MattProps operates on discrete props objects, this MattPropStream operates on the entire stream of props across time. And this lets you use like awesome RX operators like flatmap, combine latest. You can like do sideways data subscriptions. You can just debalance all these cool like async things that you can do with Rx, you can do with MattPropStream. And I don't have a bunch of time to explain how it works, but I talked about this at ReactConf, so you can watch my previous talk maybe for a full explanation of this concept. Also, I should mention that MattPropStream is technically part of a separate project called RX Recompose, but once RxJS 5 is out of beta and I can just use the observable spec, then we're just going to drop the Rx dependency and just merge this function into Recompose. So the reason I'm bringing this up is what's interesting about MattPropStream is that most other higher order components can be defined in terms of MattPropStream. Like most of them can be defined in terms of a prop stream transformation. So in other words, MattPropStream is kind of like a superset of all the other higher order components that are provided by Recompose, or likely the other higher order components that you would want to write yourself. So because of this is another property of MattPropStream. So these two examples here, are the top and the bottom, will create two separate higher order components, but with identical behavior. In the first example, we're composing together 3 higher order components that are created using MattPropStream. Like that's what we typically do. In the second example, we're instead composing together the transformations that correspond to the HOCs in the first example. We compose those together first, and then at the end, then we pass it to MattPropStream. I think this is like the distributive property, if my math isn't totally out of my brain by now. So the advantage of this second example is that it only results in a single component instance, right? That first example, you're going to get 3 things in the tree. And in the second example, you're just going to get 1, because there's only one MattPropStream. So if we combine these 2 things that we know, which is the first being that MattPropStream is kind of like a superset of all these other HOCs, and the second thing being that we can compose them in this special way in order to avoid extra component instances, then what we can do is whenever we compose using the first strategy, we'll just intelligently kind of change it to use the second strategy instead, and that lets us squash all of our HOC containers into a single component. That's pretty cool. And it turns out that like I said, most of our HOCs, except for the ones that access lifecycle methods, can actually be defined this way. So to repeat, what we're going to do is transparently change the way HOCs are combined. Or you might say we're changing the way HOCs are composed, or you might say that we're recomposing the HOCs, and I'm spelling this out because I literally just realized this naming coincidence like an hour before I came up here, and I got really excited. So yeah, I promise you that was a total accident. I didn't have this in mind when I first named this library. So the point is, with this technique, you can compose together a large number of higher order components and produce only a single container component. And that's pretty cool. Now, one problem with this is that we don't want to actually use MattPropStream for this purpose, because we don't want to require that all Recompose's users include an observable polyfill, because it's not like it doesn't have widespread adoption yet. But we can take the same basic concept and use it to achieve the same effect. So to that end, in the upcoming version of Recompose, it uses an abstraction internally that I'm tentatively calling UpdateMiddleware, but that's probably not what I'll end up calling it. It's not that important because this will be internal. But it's like an observable. It's just it represents a props transform, and it's lightweight, and it's just specifically for describing prop substates. I'm not going to show you the actual implementation, but because it will likely change. But if you know how middleware works in Redux, it's very, very, very similar. And this will merely be an implementation detail of Recompose that squashes together these components transparently whenever you use it. It's not going to require any API changes on the top. And I hope to merge and release it within the next week or so once I get good enough test coverage. And another reason I like this is that you're likely to get even better performance using Recompose now with these special higher order components than you would if you created a bunch of container components manually, at least in a lot of cases. So, to recap, we learned what higher order components are, that they're essentially parameterized container components. We learned that these small HOCs can be composed into more useful HOCs, and we learned a strategy for squashing these container components by composing PropStream transformations. So thank you. I hope you found it interesting, even though it's kind of a weird topic. And in the spirit of Christopher's talk, please come convince me why this is all a bunch of not good stuff, please.